Hello, and once again welcome to my workshop. Today I'm going to show you how to make a jig to go into a fourth axis. Primarily I made this jig or designed this jig to hold cylinders of glass or perspex, but it could just as well be wood. This isn't specific for the laser. This could also be used in the CNC router fourth axis as well. So it's a very simple process. I actually made this out of 9mm, which is 3/8 of an inch, I believe, MDF. It is a very simple jig to manufacture on the laser, and I'll be showing you on lasercut 6.1. We'll design it in lasercut 6.1, so we'll be using that as a CAD system as well, and we will cut it out on the laser. There's a few, shall we say, peculiarities of cutting MDF. It is a man-made product, and it is extremely smoky, and I would say that MDF has a lot of different types of resins. When the laser cuts through MDF, it evaporates the MDF to a gas, which is what we see as smoke and a nasty smell. And I will tell you now, if you purchase a laser, not just from me, but from anyone, if you purchase a laser, do yourself a very, very big favor. Buy a filtration unit. This is a Pacific tooling filtration system. It has 4 independent filters, 2 of which are active carbon filters. It doesn't matter whether you buy a laser from me. Whoever you buy your laser from, purchase one of these as well. Because when a laser strikes the material, it evaporates the material. That means it turns it into gas. We see it as smoke, or we smell it as a nasty smell. That substance is carcinogenic. Over a long period of time, if you have that floating around your workshop when you're using a laser, you will become seriously ill, if not fatally. So do yourself a favor. If you're considering buying a laser, definitely get one of these as well. Okay, so we're going to start now with lasercut 6.1. And really this jig, all it comprises of is 4 circles of different size, which we then glue together in pairs. So the first thing we do is we get the circle tool and we draw a circle. Then we get the pick tool up here, or highlight tool, come over and click on size. Now the first hole we want is the one in the center. Now this is going to be in the tailstock end, so it only needs to be a small one of 12mm. 12.0 by 12.0, and okay. So what we're going to do, we're going to draw all our circles first, and then we're going to go and put them in priority order. And I'll explain to you what that is about when we get there. Oh, first of all, let's get the highlight tool. Highlight this, and we're going to put this straight on one of the squares there, like that. Just makes it easier for me to line up afterwards. Now then, so what we're going to do now, we're going to draw a bigger circle, and highlight tool right click, size. Now this one is going to be, let me see, I'm just measuring up here, so this is going to be 110 millimeters. So 110 by 110, and there we go. And we're going to move this now to the center of there. Now that is one of our units. What I'll do is I'll speed this process up. I'll just fast forward this because really it's much of the same thing as draw several circles, and then I'll come back and I'll prioritize and show you why I prioritize with. So now I have all of my parts made. So what I'm going to do now is I'm going to fetch them in a little closer to save on material. I'll put this one directly over that one. About a 5mm gap in between. Just saves on material a little bit. Oh. Okay, so I'm happy there. So now I'm going to put them on different layers. And the reason for that is we don't want the outside ones cut first, because if we did do that, they'd just drop out. So we want the centers cut out first because we don't require those. So what I'm going to do now is put them all on a black layer. Okay, so we can actually leave these on a black layer because I've got a black layer there, and leave these black. So what I'm going to do is choose the outside, this one, this one, this one, and this one, and put them on a blue layer. So what this means is that whatever comes in the listing up here first, that's what will be cut first. So now we'll set up the cut-in parameters. Now, MDF can be difficult or awkward to cut, and you'll see that in a minute, because what happens is it's very smoky, and the smoke and debris does tend to absorb the laser, and in doing so make it less powerful. So you have to ramp the power up a bit, I find anyway. Let me see, 8mm a second. That should be okay actually. Now this is striking the arc then, as it were. This is the initial start of the laser. Now 90% on my machine is 100 watts. Now whatever you do, what you will need to do is find out exactly what your machine outputs in relation to the input of percentage on your computer. You can do that by using the meter on our machines. The Pacific Tooling machines, we have a amp meter. Now if you watch the amp meter, you must never let it go over 30 milliamps. Okay, because at 38 milliamps it's putting out 100 watts. If you go over that, you overdrive the laser and you will greatly shorten the life of your laser. Okay, so full power to start, that punches a hole through the material. Now for the running, for the cut, I'm going to leave it at 85 maximum and minimum power. I'm going to say, okay, calculate that, which takes just but a minute. And blue layer, exactly the same, it's already preset. And we're going to say okay for that. Okay, so when I start the laser up, I will then download or transfer that file to the laser. Okay, the lasers normally have an extraction system which extracts out of the back, out through here. With our particular model, we have another vent in the back which allows air into the plenum inside here. So air is drawn up through this table and then across. It's also drawn up at the front and across, and evacuates then all the debris and smoke. But what I personally do is, now this is black mold steel. Just standard black mold steel. Is very flat, very straight and clean. Do not use anything aluminium inside on your bed. If you have an aluminium bed, get rid of it. You shouldn't have an aluminium bed at all, because aluminium is very, very reflective. It will reflect the laser up to about 98% of the power. It can be very, very harmful. So if your laser that you have purchased has an aluminium bed of any sort, get rid of it. There should be nothing but steel inside here, and not stainless steel either, black steel. Now then, so what I do, this honeycomb is actually steel as well. It's magnetic. It is actually magnetic. It's coated so it doesn't rust. But these are Pacific Tooling machines. These machines were designed by engineers that know exactly how a laser operates or should operate or should be operated. Unfortunately, the vast majority of lasers that you can purchase off eBay are not worth half the money that you pay for them, and they are certainly not put together or designed by credible engineers. And you can quote me on that. Okay, so what we're going to do, because the debris and smoke from MDF is a great amount, we need to evacuate it quickly. And there's an added feature then in our lasers. We have a panel here at the front, the back, and there's one at that side and one that side that you can remove to put material in, which is larger than the bed. Now, It requires a key, so what I do, unlock and remove it. Just the front one. This is to give added airflow, although here on the front we have got a substantial grill to allow air to come in, to flow across the material, to evacuate the debris, as an added feature to increase the evacuation process of the material, because don't forget, the smoke will absorb the laser light and dull your laser, or it might even prevent it from cutting all the way through. So if you remove this panel, which is quite safe to do so, because when this is closed, no harmful rays can come out at all. Incidentally, while we've got this cover off, I'll point out this is where you plug the 4th axis in, right there. Okay, so what I'm going to do now, this piece of MDF is actually the full size. It's a 600 by 900, which is the actual operating template of this machine. But what I'm going to do to maximize the airflow, because don't forget the air comes up through here, it doesn't go down through, okay? To maximize the airflow, I'm going to put this sheet through this way. Oh, another feature I'll show you. I use these. These again are magnetic, but you get one off. Okay, so there's a magnet on the base. They're just little standoffs. It just gives you an air gap underneath, because when the laser cuts through and you have the air blast from the nozzle blowing the material through, it's got somewhere to escape. And it's preferable to allow the debris then to condense onto this metal and collect here rather than fill your filters up. So that's why, another reason I use this. So we'll put this in here. Nice and square. And this is in here without removing the back panel. It's got an identical panel right at the back. It's just sat up against it. So now I'll turn the laser on and put the file over, and we'll set the 0 position, and we'll run and cut this out. Right, so the first thing we need to do now is we're going to set the Z height with the automatic Z height setting tool. This machine does it all automatically. And then we'll set our 0 position in the work, and we'll cut these out. I think we'll set the Z down first. Okay, so all we do is put this steel plate directly underneath the nozzle. On the back side of the nozzle there is a proximity sensor, and that will very accurately position the nozzle a set 9.5 millimeters above the surface of the material. So here we go. That now is precisely 9 millimeters. So then we're going to track over the the X and Y and put it into a position where we close to where we think the beginning of the program will be, and then we'll do a test to see whether we are in a rough proximity of the material. So to set the 0 point or the start of the work, now it's a very simple process. It's a very simple process, and just press enter, enter, and now that's logged in and locked. So now to see whether that program that we have just written lies totally in that material, we're going to do a test which is simply this. And it does. So now we are absolutely fine to press start and cut this out. You'll notice that although I've got the door open, 99% of the smoke is actually being carried away over towards the back of the plenum then, and you can see now the smoke going down through, and I'm in no danger at all, but that is what I'm doing. I am not condoning operating the machine with the door open. It is necessary for me to do this. It's a very calculated thing that I'm doing. This is to enable you to see exactly what MDF is quite difficult material to cut because it's a very fine line into the debris bursting into flames and damaging the work on the underside and not bursting into flames. We've just about got it right because there is no flaming underneath the material, and it's looking to be a reasonable cut. You'll see some smoking on the top surface. This is unavoidable really with MDF unless I put a mask on, and when I say put a mask on I mean masking tape, and cut through that. This is a simple jig to hold material, so in this case it's not necessary. So that did that without and they are actually all cut out, which is exactly what we wanted. So now I'll retract the gantry out the way. In actual fact, I'll take it home to the datum, let it do it automatically. So that's it. We've cut our parts out. So now we'll assemble. 3, 2, 1. Okay, so here's our perspex actually, it's acrylic. It looks just like glass. It sounds a bit like glass, but it's actually acrylic. It's very good acrylic too. Okay, so this is simply put together by putting this over the nose of the chuck and opening the jaws out. Just firmly press it. And then this one fits onto the end of this. This has got a bearing on it to allow it to turn freely. And what happens is this fits in here, so it holds it nice and square. And this open mouth fits in here, like oop. Simply like this. So just push that up to the chuck, and then this just screws up. You don't have to be over tight with this, just firm, like that. Press it firm. Lock that up. Just make sure this is firm, it doesn't rotate separately from this, and there you go. And now this is set for the laser for us to zero the laser on here, and for the laser to cut our design on the outside of this vase. Obviously the bed needs to be lowered down about so far, and then I will zero this over. Now that will be the next laser video. Okay, so I've split this video up into two because you may want to see how to put a program together to etch on in a fourth axis with a laser, and some of you actually are more interested in seeing how the jig is made. A very simple jig to do a project like this. So that will be the next laser video. So I hope you've enjoyed this video, and if you would like to subscribe to my channel and press like, and come and drop in and see me again. There's now 250 videos on both combined channels, laser channel and my CNC routing and wood turning channel. So I think there's something there for everybody. And now I'll say again, it doesn't matter if you don't buy a laser from me, but whoever you buy your laser from, buy a filtration system, a good one, because you will end up being seriously ill. Now that is, you can read about that on the internet. Don't take my word for it, but I'm telling you, it's quite a serious concern within the laser community that people buy a laser and they run it in their homes, and over a period of time them or one of their family members becomes seriously ill. These are not a toy. It's fine to have as a hobby or a business in your home if you have the right equipment. And when I say the right equipment, it is my advice to you, do not buy any equipment from eBay, because eBay, unfortunately, it's a good idea, but unfortunately eBay is flooded with machines that are not worth half the money that they're asking for. Do yourself a favor, if you're genuinely interested in a CNC machine, whether it be for a CNC router or whether it be a laser, visit Pacific Tooling. I've put up 3 videos, video number 230, 231 and 232 on both my channels. 232 is the one that concerns with lasers. The other 2 are concerned with CNC routers and wood lathes. So check on there first. You know, our machines are made by highly trained professionals. They're designed and made by highly trained professionals. I've heard it said, I've had emails from different people saying, oh, you're a little bit expensive than the others. Well, that's because these machines are very good and you get your money's worth. Be very careful buying anything at all off eBay. Our machines will do absolutely what they say on their label, and absolutely what you see on YouTube that we show you, they will absolutely do. Just a little tip. More than 95% of the lasers sold, particularly on eBay, are sold on peak power outputs. Now what that means is, if you're buying a 60 watt laser advertised at 60 watts, you're going to be lucky to operate that laser at 45 watts, because the peak watt output and the actual running watts are two different things. If you run a laser on the peak output all the time, or for long periods of time, you're going to kill your laser, because it diminishes the laser's ability, it diminishes the CO2 inside the laser. This laser, for instance, this is a 100 watt laser. It's a genuine 100 watt laser output. In other words, you can run this laser at 100 watts output, continuous. The peak power of this laser is 120 watts, but you can't run it at 120 watts. You get my meaning? So what you're purchasing from somewhere like eBay, you're not getting what you think you are. With our machines, whether it be CNC routers or lasers, you do. So thank you for joining me, and pop in and see me again sometime and have a look at those videos. 230, 231 and 232. That's the product information videos for Pacific Tooling. Bye for now.